and welcome to the Signaling and Communication channel. We are kicking off the first session with a very interesting panel discussion on signaling, communication, and control 4.0. If you have any questions or comments for the speakers, then please post them in the live discussion box, which you can find in this session. With that said, I would like to ask the speakers to turn on their videos, which they have, and hand over the session to our moderator, Tom Godfrey from Arup. Tom, over to you.
Thank you, Eileen. Great to be on this conference today. I might add that it's 3 a.m. here in the UK, so apologise if I look slightly sleepy, but I've had a lot of coffee, so should be okay. Yeah, I think I want to start by each of our panelists introducing themselves, and then I'll introduce myself. So perhaps I could go to Yilong, first of all, from the LTA. Yilong, could you introduce yourself, please? I think you're on mute at the moment, Yilong.
Yeah, sorry. Hi, I'm Yilong from Land Transport Authority. I'm the Deputy Group Director for Road and Rail System Engineering that is looking after all the road and rail systems. Thank you.
Great, thank you, Yilong. And then we can go to Chan Ho Wing from MTR.
Hello, everyone. I am H.W. Chan from MTR of Hong Kong. I was an engineer by training, and now I'm taking up a position looking after the innovations introduction in MTR on the railway side. Thank you.
Thank you, Ho Wing. And now Yanto, could you introduce yourself, please?
Okay, thank you, Tom. Hello, everybody. Good morning for Asia region. My name is Yanto Yulianto from MRT Jakarta. I was involved in first implementation of CBTC at Metro Highway in Jakarta, and now I'm as division head of IT. Thank you.
Fantastic, Yanto. Thank you. Yeah. So just back to me. So Tom Godfrey. Yes, I'm the rail systems engineering lead in Arup, where my job is to build our capabilities into Arup, particularly concentrating on train control systems. And by way of background, I've spent all of my career, it seems, working on various train control systems of different varieties in different parts of the world, which has been very interesting. Highlights might be the Victoria Line resignaling project in the UK, the Changi Airport line extension in Singapore, the Klang Valley MRT Line 1 in Kuala Lumpur, Delhi Line 7, and some projects in China which I was involved in, Shenzhen Line 3 and also Tianjin's Line 2 and 3. So I've had quite an interesting experience in the world of train control systems, and it's great pleasure to be here to run this session. So, okay, by way of introduction, before we get into the questions, of course, in our little pre-meet, we kind of thought, well, what exactly is signalling, communications and control 4.0? So we did a little bit of research, and I'll just give you a quick summary. So the term 4.0, generally speaking, it actually relates to what was known as the fourth industrial revolution, which was something that was actually initiated in Germany and published in April 2013. And the fourth industrial revolution has got four major principles. I'll quickly run through them. The first one is about interconnection, which is the ability of machines, devices, sensors, and people to connect and communicate with each other via the internet. The second one is, it was called information transparency, but I think you can more or less call it data. And this is all about collecting lots and lots of data to help make decisions and identify areas of improvement. The third principle is technical assistance. So this is about systems to help humans make decisions. And then the fourth main principle is about decentralized decisions. So this is all about systems being able to make decisions by themselves and as autonomously as possible. So that's the general part. Then specifically, and this was quite good, I was actually privileged to attend this talk by a guy called Joseph Doppelbauer, who's actually the executive director of the European Rail Agency. And in 2018, he published a paper called Command and Control 4.0, which in a way was the rail industry's take on the fourth industrial revolution. And in Joseph's paper, and I will base a lot of the questions today on that paper, he actually made an analogy of train control systems to an animal, which it seems strange, but it was actually quite a good analogy. So what he said is that in the future, the 4.0 train control systems will have 3 control loops. So it's about the principle of doing decisions as much as possible at the lower level. So the innermost level, or the lowest level, is the vehicle level. And this is all about introducing sensors, rather like autonomous cars, so that the vehicle can react to stimuli very, very quickly by itself. So then the middle level, he called it the route server level. In signaling terminology, we can sometimes think of route server as the interlocking and the block processor combined, and actually hosted perhaps on the train or maybe in the cloud. And the key thing about this middle level, the local level, is that it introduces the train-to-train communication concept. And he likened the middle level to the spinal cord of an animal, where the spinal cord can actually coordinate decisions for several limbs, but not need to go back to the brain. Okay, so then that leads to the highest level of Command and Control 4.0, which of course is the brain level, which is the traffic management system. I know in our world we have many names for it, but the traffic management system is therefore handling all of the global and strategic decisions. And this leads to a more efficient architecture with overall better performance and availability. So I hope that was a good intro to what at least we consider to be 4.0. And I'm going to now go straight into question 1, okay, which I'm going to direct to you, Yilong. And my question is, you know, Joseph's paper on Command and Control 4.0, it was very much about the European train control system and the evolution of that system. Now, in mass transit, the prevailing technology is communication-based train control, CBTC. And I wondered what you thought about, do we have in the mass transit industry, do we have appetite for 4.0 in CBTC?
Okay.
Over to you.
Okay, thanks, Tom. I mean, perhaps I can start to talk a bit on what we mean by the Industry 4.0, what you said earlier, the fourth industrial revolutions. Basically, Industry 4.0 is actually based on robotization. Robotization actually goes beyond mechanization, which was introduced in Industry 3.0. It actually enables machines to perform more complex tasks. Industry 4.0 actually take emphasis on digital technologies to the whole new level with the help of interconnectivity, as we just mentioned earlier, through Internet of Things, access to real-time data, and the introduction of cyber physical systems. Industry 4.0 actually offer a more comprehensive, interlinked machine-to-machine communication and a holistic approach to manufacturing. So the analogy of Industry 4.0 for our railway is actually Command and Control 4.0, as we just explained earlier. So, in fact, if you look at the modern CBTC today, they are more intelligent. It has either automated the repetitive tasks that used to be performed by the train operator or transfer the train operator's job to Operation Control Center for great automation level 4 systems. The modern CBTC system also designed for Industry 4.0 have gone a step further by being more intelligent and, as what you said earlier, digitize the operational data such as health status for ease of diagnostics and condition monitoring, for example. Probably what is missing here is the equivalent of machine-to-machine communication in Industry 4.0 for railway. which is the train-to-train communication, as or you just rightly explained earlier, the decentralized controls. In fact, if you look around the world on the train or CBTC development, we can see that Alstom and Thales are actually working on, we call the train-centric or train-to-train communications. In fact, we understand that Alstom is currently working on a project in Shenzhen metros to deliver the train-centric signaling systems. The issue that most of us as a client here face today is not so much on command and control 4.0 or industry 4.0. It is actually, there is no standards or no standardized CBTC system to the extent of European train control system, if you look at that in ETCS. But we separately, we understand that both New York City Transit and Paris Metro are working to standardize the CBTC system that they procure. And in New York City Transit, they call the project interoperability projects, and in Paris, they call them OTIS, which use different names. So, as to whether there's appetite for 4.0 style of CBTC, I think the industry is working towards that. So, Poppy, I'll just stop here. So I think the industry.
Thank you. Yeah, thank you, Yilong. It's a very comprehensive answer. I'll just ask my other panelists if they've got anything they would like to add to your answer there, Yanto and Ho-Wing. Oh, it was a very comprehensive answer though, so if you don't have anything, it's okay.
From Long.
Yeah,
agree with your opinion.
Yeah, I think you know, this business of standardization is a good one that you mentioned there at the end, Yilong. Of course, that is in a way the Achilles heel of CBTC, and as you rightly say, there have been initiatives out there in New York and places to do some level of standardization. But as we all know, it's a very big task, and you probably know that for ETCS, you know, the European Train Control System, that standardization was driven very much by the interoperability, the need for interoperability between the countries, and it required a very big investment, you know, from the EU to make it happen over decades, in fact. So it is a challenge. But let's move on to the next question then. So I'm going to direct this question to you, Ho-Wing. And the question is, in Command and Control 4.0, it talks a lot about the impact of new technology for train localization and train integrity. And I wondered, what experiences have you had in this area, and what sort of improvements do you anticipate in the future?
Right, maybe first of all, we have to get to the very fundamental reasons why we need to locate the train. Right. Historically, why we need to locate the train, because it's for safety reasons. Because we do not want to have two trains in the same section of track. That's why if you are coming from the rail industry, the terms track circuit or axle counter would not be something new to you. Because by doing so, then we know there's a particular train in a particular section of track, so that I'm not going to route another train into this particular section of track. But gradually, the localization of the train has moved from safety to service. And we would like to determine the location of the train so that we could increase the train frequencies. Sometimes we call it the headway. And in order to do so, then we have to make our train a little bit more intelligent. In the past, all the intelligence resides on the track side, on the control center. That is, only the control center knows where's the train. And the control center determined by the signaling, through the signaling system, to ask the train to stop, to wait, or to proceed. But now, if we have to increase the frequencies and the carrying capacity of a line, a train, then perhaps we have to move the intelligence to the onboard train equipment. Once we move on to that, then we will have to think about, okay, in that case, any references we could make from the automobile industry. Today, we have this driverless car or autopiloting car. What have been doing from that particular industry that we could draw some references to us. One thing is about the GPS. GPS is a way that actually we could determine the location of the trains. In the past, the GPS is not as accurate enough to actually locate a train, because if you have two parallel trains running in two parallel sections of track next to each other, the GPS may not be able to identify exactly the location of the train on a particular track. And the next one we are now moving on is that if I have a intelligent enough train-borne equipment, could I actually install something like radar or laser or CCTV doing video imaging so that I could locate the train by looking around the surroundings? I think this is a good move. In fact, a lot of trains are now having cameras fitted to look at the front of the path, so that there will be some kind of analytic performed to help the train to locate themselves. But I would imagine it would still take some time for this analytics to be mature enough to manage a train running in high speed, because analytics do take time. Therefore, we still need to have something else to supplement on that. Trying to draw from the Industry 4.0, in fact, when they are talking about sensors, very often they are talking about some sensors called the RFID. This RFID would help a lot in the industry productions. In fact, it would also help in the railway, because RFID have an excellent positioning accuracy. If I go past a particular RFID, I know that the exact location that I've gone through. But RFID also have its different form or characteristics. To make the RFID working in a train environment, perhaps we should have the reader on the train and the tag, the RFID tag along the track, so that the train actually by reading this tag know exactly the position of the train. The next part is about the integrity of the system. And in the past, we relied heavily on the reliability of the system, like the track circuit or the axle counter, to ensure the integrity of this kind of protection. Moving on, in the futures, I think we need to combine several solutions and several technology in order to ensure the same or even better integrity in the future. In particular, if we are going to the so-called GOA4, that is the fully automatic train operation, where eventually we will not have a train captain or driver will try to steer the train, but all these are being done automatically. So I would imagine the RFID, the GPS, the video imaging are all contributing to the reliability of the train operation. Thank you.
Well, thank you, Ho-Wing. Yeah, a very comprehensive answer again. So let me ask our other panelists if they would like to add anything to that answer, Yilong or Yanto.
Perhaps I can just add on to what Ho-Wing has said a while ago. I think if you look at the development today, it seems that there is another parallel track running on train protection. Is this something called advanced obstacle detection systems, whereby it will be able to detect any obstacle or any object in front of the train, whether is it a train or whether is it a leftover obstacle on the tracks. We understand that there are several companies in the world working on this. For example, Thales is working in New York City to demonstrate they can even read the road sign, the speed limit signs, just like the autonomous vehicles. So they will just slow down the train as it's approaching a curve. It can also read the signal lights. If the signal aspect is red, it's supposed to stop the train. Then in China, you have this company called TCT. It's also developing something similar. So it seems that there's another parallel track going on to develop this kind of sensors. But I presume at the end of the day, whether is it a competition to signaling or is it complementary to a signaling system, I suppose it can be a complementary to a signaling system in the event of integrated operations. For example, you are under manual driving, or you are at an area whereby the area is not signalized, unsignalized. For example, in mainline railway, may not be so much for metro systems. Yeah.
We may have lost Yulong there. Sorry, I may have lost your last point there, Yulong. Can you hear me still? Yes.
Yes.
Yeah.
Can you hear me?
Good. Okay. Yes. Yeah. I can hear you. Yes. Yeah. No, I think I got most of it. So thank you very much. Yanto, is there anything else you would like to add? I think you're on mute. Yeah. I would just like to say, maybe a couple of things there as well. Is that there is one of the good things I think about let's say a number of sensors available and coming a lot from autonomous cars and from other industries, is that you can have this concept of sensor fusion. So you can have many sensors all measuring speed and distance. And what this means is that if one sensor should fail or become unavailable, you can still run off the others. Now it's not a new concept. I mean, that's been around for a while, because a lot of trains in the existing odometry systems, they will use axle mounted tachometers and maybe an accelerometer or a radar. But I think in 4.0, there's that concept can be extended a lot. And actually you can have many more types of sensors all doing the same thing, and therefore making a more available system. And also on that point, the other thing is that in degraded mode, if things fail, and they do, as we know, sometimes we all hear about them, sometimes a railway, a CBTC railway will have to go into some form of degraded mode. And there have actually been some incidents on some railways in degraded mode, collisions and things, low speed, but it has happened. And I think, with these kind of sensors, that, proximity sensors, the vehicle, in a way, when it's in degraded mode, it should be able to protect itself better from that kind of thing in the future when it's in a degraded mode. So I think these are really interesting developments, and thank you, Ho-Wing, for a very comprehensive response. So Yanto, I'm going to move to you now. And actually this next question is actually, in a way, it's an extension of what we just discussed. So in the command and control paper, Joseph mentioned that he said sensors on railway vehicles could turn every vehicle into an inspection vehicle. And I wanted to know, can you see this happening in your world?
Well, technically, I think it's possible. Technically, it's possible.
Yeah.
But one thing maybe we must consider is, can we trust or can we feel that our human sensing will be replaced by the machine? Many sensor we can talk. Maybe we can talk about RFID or sensor by the satellite. For me, impossible, but how the operator will be trust is depend on the reliability or the age of the technology itself. Capture all the image and then process it, then send to the driver or send to the GOA4, then it will be read and respond by the vehicle. I think will be quite very critical data. So
yes,
yeah,
I think this is
a trust.
Yeah, I think, Yanto, that's a really key point, isn't it? About how much can you really replace the human with the machine. I'll just say something and then open it up to our panelists, because I think, for me, the one that actually Ho-Wing mentioned about cameras on vehicles, I think this is a very it's happening, and we're almost there, but not quite. But I'm very sure that it will become commonplace on railways to have this in the future, because with these cameras you can pick up the data and then you can use, collect the data and then use AI to actually analyze and detect patterns. For instance, in the railhead. So if you've got cameras pointing at the track, it's quite easy in a way to if you've got lots of data to start detecting changes and patterns and develop AI algorithms to help, with that. But then, of course, you can't just jump to that. There has to be a transition from the human to the machine.
Yeah.
And maybe you can never perfectly go completely to the machine. Maybe the human still has to be there, even in the most futuristic systems, overseeing. I'm not sure. But let me hand over to Yilong and Ho Wing and see if they've got anything to add on that topic.
About the cameras, certainly I think the onboard camera would help because it would provide a secondary input to the train about anything is really obstructing or intruding in the track ahead. But I would imagine if we are running a train at a rather high speed, the camera itself may not have sufficient resolution to do it in a quick distance away from the intruding object. So sometimes we also need to have some trackside cameras to supplement, in particular in the curved track, where actually the cameras on board cannot see far from the objects. Okay. Mm-hmm.
Yeah, that's a good point. Yilong, anything else on that one?
I suppose when you talk about cameras, one thing that if you talk about camera from a signaling engineer perspective, you'll need to consider the safety integrity of a cameras. Whether the cameras and the processing itself can they do can they perform safety functions? And what is the integrity of the images that you collected? So I suppose that this is a challenge that, I mean, although we understand that camera has been widely used in autonomous vehicles, but then when you come to railway context, how do you then do a safety assessment or safety assertion that camera itself is a Shield-4 system? I think that's a challenge today.
Yeah, I think it is. I mean, there are ways I think to do it, but I get your point. I mean, normally, by having more, several cameras and comparing a bit like we do with 2 out of 2 type systems.
Yes.
But extending that principle is the way. But I get it. It's always complex to make that argument. So I think it's possible to do, but I'm not saying it's easy. It's very challenging.
Can we add something? Until now, I still cannot find that the camera have a Shield-4 certificate.
No, I don't think it will have a Shield-4 certificate. I think the only way you can do this is by combining several cameras and having your processors checking, doing cross-checking of the imagery and that sort of thing. But yeah. I want to
for secondary sensor is possible, right? But not for the main sensor.
Yeah.
Okay.
As by the way, we've had a question in from someone called Jacob Tam, and I thought maybe before we go on to the next question, I'll ask this question. Why not? So thank you, Jacob. So Jacob's question is for those signaling systems in MTR. So I guess this one's for you, Ho Wing. The asset life is going to expire, or has already expired. How can these aging systems maintain high performance to upkeep the high reliability? So I think in answering this question, if you could sort of try to bring in the 4.0, that would be very good, Ho Wing.
Right, thank you very much. In fact, yes, we always have to face the issues that our signaling system is running for some time, and we have to extend its asset life, right, as long as possible, because investment into the signaling system is really an issue. But that doesn't mean that we are going to lose the performance of this aging system or the signaling system due to many years of operation. Why? Because actually, while we are now having the legacy signaling system, we still could actually have something put into the system and try to make it more reliable. And the 4.0 in fact allowed us to adding into some secondary control or performance operations so that we could actually bring up the reliability and also the performance. Thank you.
Okay, brilliant, Ho Wing. I think what we'll do, because that was an MTR. Well, no, let me just ask, because I mean, obviously, Yanto and Yilong, you also have that problem in a way. So, would you like to add anything about assets that are coming to the end of their life and how 4.0 can help?
I suppose if you talk about 4.0 perspective in digitalizations, or probably may not be so much in digitalizing the signals or the information that that the system can tell you. But definitely you can digitalize the records that you have. So by digitalizing the record, you are able to go back to the history and understand for example, the aging system. Where do you need to focus more? Where do you need more? Where do you think emphasis should be placed on? Which means that more maintenance should be required.
Yeah.
So in that sense, I think 4.0 will be able to help as well.
Yes. Yeah, I agree as well. I mean, we see now actually that you can actually put sensors on your existing assets quite easily. There's sensors that you can clip around cables to measure current running through cables, and then you can start monitoring things like point machines. You can there's a very interesting new technology called fiber optic acoustic sensing, where you can use fiber optic cables, that are already existing, and you can actually measure vibrations and detect, maybe people coming onto the railway, or even vehicles, or odd things, just by using existing fiber optic cables and clever back-end equipment to using the backscattering principle. So there's a lot to be done. I think you're right. You can with aging assets, with the 4.0 concept, to acquire data and then use it to make good decisions on how to keep the asset going. Okay, so thank you, Jacob. So we'll go on to the next of my questions then, which I would like to address to Ho Wing again. Let me just make sure. Yes, that is. Oh no, sorry. The next question is. I'm going to address it to you, Yilong. Sorry. So, Command and Control 4.0 talks about these different control loops: the inner, the middle, and the highest level. And the middle level involves communications between trains and ideas such as moving the interlocking onto the train. And I know in your intro you discussed this briefly. But what are your thoughts on this, and what do you see as the main benefits of doing that?
I suppose the whole thinking behind the train-centric signaling system is actually to reduce the number of physical assets on the tracks. So as to reduce the maintenance effort and costings, thereby making railway operations more economic. The infrastructure need to be made cheaper and more efficient, which is what the railway is about. Then to optimize and also to optimize the financial viability of the asset use. And hence there is a shift from fixed costs in the infrastructure to variable costs, with most of the intelligent move to the trains. I suppose this is the impetus driving behind all these train-centric signaling systems. Because at the end of the day, if you can reduce the fixed cost, then it is obviously more important on route having less than traffic, which means that you need not have to invest on the trackside infrastructure, whereby one train, one day you only have one train passing by. For example, some of the intercity or at the rural areas. In this case, if we put all onto the train, which means that the mobile asset should be able to roam freely in an integrated rail areas. Having said this, today there is no single, as what you say today, for ETCS, you are trying to have a standards. But within the metro itself, today all our metro, we don't have a standard CBTC systems. So in this case, how then we do it? We also know that different operators have different operating rules. Even within Singapore, we have two different operators. We can see that the operating rules are also different. So how are you going to make this possible? Unless both operators have the same operating rules, then you can design a signaling principle whereby train can roam around the networks. But having said all this, a train-centric signaling system, as you know, the signaling engineers is always quite conservative. So this requires a major mindset and rethinking of how the safety assertion is done. Because traditionally, as what Ho Wing mentioned earlier, signaling engineer will prefer a physical means such as track circuit or access counter to confirm that the point and crossing area is clear or free of any train before allowing the point to move. However, in order to reap the full benefit of train-centric signaling system, that you shouldn't have a track circuit or there is no track circuit nor access counter to prove that the track is clear. How you prove that the track is clear is to the train position reportings. And whether the point switch will best be centrally controlled from an interlocking or train control. You can still do it two ways. Whether it's a train control or whether you call inner or your middles will have to be developed over time. So this is a whole new thinking. The greater operation will need to be developed as well, because this is a whole new shift in the mindset. So benefit of train-centric signaling system are actually to saving in equipment, improve ability. However, the challenge are actually safety integrities. That each train need to reserve and release the switch of points. Another challenge of train-centric signaling system is actually integrated modes. In the event you have a communication system fail. So it's just my thought.
No, I think it's very, you echo exactly what I think as well, Yulong, about that. I think that's a very comprehensive answer. Thank you. Would anyone else like to add to Yulong's answer there? If not, we've got a few interesting questions that have popped up, which I might just go on to ask some of these questions before I go on to my next one. So perhaps we'll take the question from Stanley, who mentioned his question is, do you think cybersecurity is top of mind in the rail industry? What else can be done to ensure security and safety? And I think for this one, maybe I will ask, if you don't mind, Yanto, could you take that one on cybersecurity? Give us your thoughts. Is it top of your mind?
Yeah, actually, it will be new. I don't want to say it's problem. Yeah, it will be new issue, right? Between the safety and between the transport system and then the signaling itself.
Yes.
Nobody can ensure, but we can mitigate it, I think. So back to the question, what else can be done to ensure the security and safety? What can we do is always upgrade our safety and never satisfying about the safety.
Yeah. I mean, I must admit, I think in the railway industry, we're all learning a lot about cybersecurity, and you probably know that there's some new standards. I think they came out into IEC standards about cybersecurity, which most railway authorities are starting to use now. And I had some experience of deploying these on a project I've been working on, and it's very interesting how it's done. But essentially, it uses a risk assessment technique. And then you need to look at your signaling and control architecture and decide which parts of the architecture are the highest risk, if you like, and then put additional protections in. And what I always find with cybersecurity is it sounds very complex, but actually some of the techniques to protect are actually rather simple. Like, ensuring that your key servers are actually in secure locations, making sure that ports are physically close so that people can't just connect devices, stuff like this. I mean, obviously there are some very challenging aspects to cybersecurity, but I think the industry, in my mind, the industry is really taking this seriously, and I think that standard that I mentioned, the IEC standards on cybersecurity, are helping us all to do it the right way. Would anyone else like to add anything to that question from Stanley about cybersecurity?
Hi, Tom, may I try?
Yeah, yes, please.
Well, I guess for the rail industry, people are more concerned about safety than the cybersecurity in general. For some historical reasons, because cybersecurity really has a very short history so far. And in the past, most of these signaling systems are called a isolated system where we have no connection to the outside world. And because of that, we believe that the risks of having a cybersecurity threat would be rather low, and therefore it would not be as critical as a safety systems. But gradually, if we are now moving to the 4.0 system, where we heavily rely on those routers or radio connections, then we have to accept the fact that this would be an emerging demand to have a secure system of doing that. Just like the IT system, I think we could do a lot of things to make it secure, because we do encryption or resilience in the design to ensure that it is as secure as possible. But I would also imagine that we really need to have a particular cybersecurity standard just for the railway, not just for the in general terms. Just so happened, I was also working in the UITP working group on the cybersecurity, and we are aware that actually there is an emerging industrial standard for railway on cybersecurity coming out. May not be this year, or maybe next year. Well, it is based on some of the, I would say, the industry standard in general, but tailored a little bit towards the railway industry. So we are looking forward to that, because once with this standard issue, then we have at least something to follow as the first step. Another one about cybersecurity is not on the design or the system solution itself, is the practice of the users and the operator, which is very important. So we also need to really tighten the awareness of the staff working on the system to make sure that you're not going to plug an unidentified USB into the system, or you are not going to make allow someone unknown to ride on your Wi-Fi signaling system for any reasons. Thank you.
Yeah, I think that last point you made there, Ho-Wing, is an excellent point, actually. Yeah, because I think you know, we a lot of us naturally, I certainly fall into the trap of thinking all the time about the design of the system, but actually, you know, these systems are going to be in operation for decades sometimes, and actually that is the time when, yes, if the operation, if something happens, if someone comes along and puts a USB stick into a device, that all of the careful design that you've done can unravel. So this is really important. A good point you made there. Well, look, I'll move on now to another question, which I will actually this one is for you, Ho-Wing. My question here is reduction in trackside equipment is a big theme in Command and Control 4.0. And I wanted to know how much do you agree with that aim? And do you think it is actually possible to remove all of the trackside assets except for switch machines?
I guess around the world, there are two reasons why we would like to reduce the trackside equipment. The first one is the investment, because during trackside installation, putting the equipment along the track is a costly solution. But there's another reason. It tries to maintain the trackside equipment is even more an issue. For example, in the case of Hong Kong, we only have around 2 hours during the night time that actually we get down to the trackside, the tunnel, to do the maintenance or to the replacement. Not mentioning that if we are going to put something new, the new installation has to compete for this 2 hours window with those maintenance activity. That's why there's really a drive to try to reduce the trackside equipment. So we always believe that where in the futures, with the advancement in the 4.0 systems, we could be able to reduce some of the trackside equipment. But I would not say that we could actually eliminate all the trackside equipment. Say, for example, we still need to have a point machine to steer the train to a different track. This part of the equipment has to be on the track. But I think what we are trying to do is to try to simplify the system to locate the train. So therefore, that's why earlier we talked about, could we actually get away with the track circuit, get away with the axle counter, by replacing with some of the wireless solution that will allow us to do the locating of the train. But I will imagine, as earlier I mentioned by me, is that actually we are also introducing something new to the trackside, say for example, the RFID. So I think we have to strike a balance, is to make sure that we are not reducing the trackside equipment for the reasons of reducing it. I think there's much a good reason for that. But we could reduce it and replacing with something that are more reliable, less maintenance, so that we could maintain the train operation without the headache of competing for the maintenance window during the night time. Thank you.
Yeah, thank you, Ho-Wing. Would Yanto or Yilong like to add to that answer?
Okay, maybe guys, just add on to what Ho-Wing he just said.
Yeah.
What I fully agree with what he said. Actually, I don't think at this juncture you can totally eliminate all the trackside equipment. Probably you can find an alternative mean whereby something is more reliable, something that requires lesser maintenance than what you have today. For example, your your track circuit or your axle counters. Because at the end of the day, whenever you have a system failure, recovery or degraded operation is something that you need to consider. So although the probability of that occurring should be low, but when that happens, you must make sure that you are able to do it confidently, you are able to recover it confidently. So without having a system on the track to tell you where the train is, I think that will make the recovery operation a bit more cumbersome, a lot more cumbersome. Yeah. That's all. Thanks.
Yes. Yeah, it's a trade-off, isn't it? Because you on the one hand you can save the maintenance and the cost of all of this trackside equipment, but then we all know that sometimes you will have to go into degraded mode. Things do fail, and then you know that even though it doesn't happen very often, it can cause a big impact. So you have to kind of balance these. I suppose the thing is with the 4.0 is that with the improvement in availability of these systems, and also what we mentioned earlier about the fact that at the vehicle level, with all of these additional sensors, you know, and also decision support systems, that it will be easier and safer to be in. You know, number one, it'll be more available, so less need for degraded mode. Number two, when you are in degraded mode, there will be better safety and better facilities to enable you to run in degraded mode. I think
for example, using advanced obstacle detection system. I thought we just talked about earlier.
Yes. So very interesting. Okay, so I'm going to move on to the next question, which I'm going to address to you, Yanto. And this is about communications. Because as we see, 4.0 has an even greater reliance on communication. In particular, what we mentioned about bringing in the concept of train-to-train communication. And we know that the UIC is working on the future rail mobile communication system. And, you know, there's a lot of themes here about having bearer independency, IP communication, upward compatibility, migration. So I wanted to know, what are your thoughts on this topic of communication, and what is most important to you, and what sort of challenges do you see?
I see. Thanks, Tom. Let's think about the standard. Back to Mr. Chan's opinion, we must have one standard that we can ensure which technology we can follow. So maybe we can talk about the migration itself. After we have the standard, maybe the Europe already have the standard itself. So what we need is migrate to the newest technology. So it will become more safe for us to use the newest standard. I think we can talk about the migration and also the security itself. After we migrate, we must ensure that it's still safe as it is.
Yes, I think you know, my take on it is that, you know, with communication, I mean, if you take the European Train Control System, they specified GSMR, you know, is a specific communication system to be used, but in the future communication system, they want to move away from that and actually consider that the communication system itself, in a way, is like a black box. And as long as you define, the protocol, which is IP internet protocol, and you have the relevant, safety and security layers, then it should not matter what the communication bearer is, whether it's Wi-Fi or GSM or 5G or whatever. It should not matter. And I think this is the general theme, but it is really difficult for the industry to handle this, because every country has got its own rules about the frequency spectrum and what parts of the frequency spectrum you can use. So let me open it up to Yilong and Ho Wing if they've got anything to add on this topic of communication.
I suppose you talk about communication. Today we understand that there is a UIC initiative called FRMCS, Future Real Mobile Communication Systems. So they are looking at how to push the industry to develop a system whereby it can be used by, whether it's ETCS or initially was designed to replace GSMR, but we understand that now it has been extended to also see whether the metro environment can also be used. So one area that they are exploring today, I understand, is looking at how to use 5G. Because we know that 5G in terms of bandwidth is a lot. So they want to see how to optimize the 5G, whether is it using dedicated frequency or is it through a mobile network operator. That is something that I think in this month IRSE newsletter, you can see there's a debate on that. Whether is it to go for dedicated frequency or whether is it to subscribe from the mobile network operators on this 5G spectrum.
I think one in my experience anyway, in railways, what you come to realize is that the needs of a train control system, it's the most important is about the timeliness of the data throughput, that it can there's minimal latency and the messages keep coming through. And a lot of these very modern communication systems are not really tailored for that, but you can tailor it. But if you're not careful, a lot of these systems can have very clever self-healing diagnostics, which are great for other systems, but for a railway system, not so good, because you need those messages to come through. So what I've realized with these modern communication systems is it's really important that they are configured to the needs of the railway system. Having loads and loads of bandwidth is maybe not, it's useful, but maybe not the most important thing for us in train control. But okay, let's move on. We're kind of coming to the end of the session. So I wanted to ask this question, and this is actually for you, Yilong. It's about people and competence. So I think we've just got time for this one. So as the industry moves towards Command and Control 4.0, what do you see as the main challenges for the competence of our staff, particularly for engineers, operators and maintainers?
I suppose this is quite a big challenge for signaling engineers, because the skill set and competency of a signaling engineer has changed over the years, especially with the development of modern CBTC systems. In the past, as a signaling engineer, what you need to focus is actually on signaling principles. Now, besides understanding or besides being proficient with the signaling principle, you also need to have a good understanding of software engineering. And increasingly, with the pervasive use of software and wireless communication, you also need to understand radio communications. So the latest development of what required from a signaling engineer is on, as what some of the question has been raised earlier, is on cyber security. Because you're looking at the signaling system, you cannot just apply a traditional cyber security of an information system onto a signaling system. Because whether is it a signaling system or the command and control system, typically is designed to last for 15 to 20 years. And how are you going to keep up with the pace of the ever-changing needs of the cybersecurity. So that require a very fine balance between cybersecurity and between signaling principles. Because as what Ho-Wing has said earlier is that signaling, I said, is very expensive. And to renew a signaling asset, even more difficult to do it. So how do you then make sure that the asset that you have is good enough to protect from the from the cybersecurity?
Yeah. I think it's certainly you know, especially you know, with a lot of us, you know, I'm not saying I'm not trying to work out people's ages, but a lot of us, let's say myself, when I started in this industry, I was sort of dealing with things like relay interlockings and things like that, and everything has moved. So yeah, well, no, not that old, not that. But
now you're struggling with IT, right?
But you know, I mean, although university at the time there was some programming, that is so old now, and you know, I've certainly felt the need in my career to have to upskill. You know, it's almost you kind of have to force yourself to do it, otherwise you can get left behind. And I think it's kind of incumbent on organisations to try to help their staff, you know, do that, because it's so easy to get left behind. And once you're left behind, then I think mentally, when you see these young people who are so computer savvy come along, it's almost you kind of think, well, I'm not sure if I can really do it, because they it's almost in their DNA, and you kind of think, oh, you know, I was from a different era. So I think it's really important, especially for older staff, to kind of help them upskill all the time. Yeah. Anyone else would like to add to that?
Just a quick one. I think there are two ways of actually improving the staff competency to adoption of the new technology. The first one has already been mentioned, is that actually we upskilling our signaling engineers with all the new skills, like the IoT, cloud technologies, or software and analytics. Another way is to try to bring those new generation with those AI technologies, software, IoT, or cloud knowledge, to bring them into the signaling industry. So I think that would be another way of actually improving the competency, because they may be able to learn something from the signaling engineers, and they could work hand in hand together. Thank you.
Yeah, very good point there, Ho-Wing. So look, I think given that the time is, we've got 3 minutes to go, so I think that means that we can sort of close the session. We did get some more questions from people. Well, I'll talk to the organisers about maybe whether we can collect those and we can answer them offline. And thank you for those that did contribute with questions. Very grateful for that. And then I should thank the panelists very, very much for some great insights from your respective areas. Really, really interesting discussion. I think we could easily go on longer. But for me personally, I will probably go back to sleep now, because it is the middle of the night here in the UK. And thank you also to the organisers, to Eileen. Thank you for setting this up. And yeah, that's it. So I think that's the end of the session. I'm not sure if I should say anything else. Perhaps Eileen, is she there? Do you need to do anything?
Yeah, no, I'm just gonna wrap it up.
Yeah.
Okay. I guess, yeah, Tom is right. There are still some questions from the attendees that are left unanswered. So maybe the four of you can go into the event platform and go into the live discussion box and see if you want to answer and reach out to the questions that have been posted. Again, many thanks to Tom for moderating the session, and of course to our panel of speakers for sharing. Arup and MTR both have virtual booth at the event, so do make sure to visit them. That concludes this session, and we hope to see you in the next one. Thank you so much.
Okay, thank you, Tom.
Thank you.
For guiding us.
Bye-bye.
Thank you.
Nice
Bye-bye.
discussion. Thank you.
Thank you. Bye-bye.